their collider to open up a portal to communicate with extraterrestrial beings.
Wow.
And one of them are the occupants from 3i.
A magnetic gateway has opened on the sun, just as an interstellar visitor slips behind the solar glare. A fast solar wind races for Earth, and scientists watch for the rare, perfect coupling that can light our skies and shake our technology. At the same time, a sudden flurry of strong earthquakes tests our instinct to link cosmic weather with ground truth. This is the story of data, debate, and a comet that may change the rules. Solar gate opens. A coronal hole is not a puncture in the sun, but a region where the hot atmosphere thins and magnetic field lines unhook from the surface and stream into space. Most solar magnetic fields loop back on themselves, trapping plasma in bright arcs. Inside a coronal hole, those lines open like a gate, letting charged particles pour outward at extraordinary speed. On extreme ultraviolet images, these zones look like dark, yawning gaps that can stretch for thousands of kilometers, sometimes spanning the equator. When a coronal hole crosses the sun's midline, it forms a trans-equatorial highway for solar wind, linking north and south hemispheres and channeling energy straight toward the planets. In late September and October 2025, pseudo and Aya imagery revealed an unusually broad, mostly unipolar coronal hole bridging the hemispheres. Magnetograms confirmed a negative, open field, an arrangement rare outside solar minimum. That open structure allowed a high-speed stream, clocked near 700 kilometers per second, to break free and sweep through the inner solar system. Space weather physicist Dr. Tamitha Skov calls such regions magnetic exhaust vents, places where the sun's plasma doesn't simmer but surges outward. Direction and polarity matter. When the sun's open field points earthward, our magnetic shield faces a focused, relentless blast. This is the setup behind a perfect coupling event. The magnetic door stands open, the wind is fast, and Earth sits squarely in the path. Magnetic clash with Earth. Solar wind doesn't simply brush past our planet, it crowds Earth's magnetic shield and forces a contest at the boundary where solar and terrestrial fields meet. There, the interplanetary magnetic field, the IMF, acts like a key. In October 2025, the IMF turned sharply southward and held near 12 nanotesla. Because Earth's field points north, opposite directions, allowed the fields to snap together in magnetic reconnection, opening gates for solar energy to rush into the magnetosphere. The consequences are visible and practical. Power grid fluctuations, satellite drag, and auroras that wander far beyond the usual high-latitude ovals. On the night of October 12th, curtains of light rippled as far south as Michigan and Maine, classic evidence of efficient sun-Earth coupling. With the system so primed, even moderate gusts or polarity flips send ripples through the global electrical environment, changing the upper atmosphere and nudging radio, navigation, and spacecraft operations. That same week brought a cluster of magnitude 7 earthquakes around the Pacific Rim. Online theories bloomed. Did the solar wind or the passage of a comet trigger the spike? The long-term record says otherwise. Earth averages about 15, magnitude 7 or larger quakes per year, and this week's count fits that statistical baseline. No mainstream seismology study has found a reliable, reproducible link between solar storms and tectonic timing. Meta-analyses spanning decades show no robust pattern. Some fringe ideas invoke ionospheric coupling or tiny changes in Earth's rotation, but they remain unproven. As NOAA forecaster Michael Former puts it, the burden of proof rests with those claiming a connection. Until there is a mechanism and a clear statistical anomaly, science treats these overlaps as coincidence, not causation. Interstellar messenger Atlas. Amid the solar drama, a rarer traveler enters the stage. 3I/ Atlas is only the third interstellar object ever confirmed. Its chemistry challenges expectations. Most comets in our solar system exhale water vapor, but 3I/ Atlas is dominated by carbon dioxide, outgassing at rates roughly 8 times higher than water, a signature more typical of the deep freeze beyond Neptune than the inner system we know. Spectroscopy from ground and space. Telescopes paints a picture of a compact nucleus smaller than a kilometer, yet active enough to shed material at up to 4 kilograms per second, even at 4 to 5 astronomical units from the sun. Its dust grains skew large and heavy, favoring a faint, asymmetric haze instead of the classic long, glowing tail. The rotation period, just over 16 hours, matches the restless tumbling seen in other active comets. Surface chemistry rich in organics, paired with a high CO2 to H2O ratio, sets it further apart. As one S2 mission scientist put it, this is a messenger from another star system, carrying a recipe we have never tasted. The question is how that recipe responds to the sun's heat and what survives perihelion. As the solar wind buffeted Earth, 3I/Atlas slipped behind the sun, invisible to ground-based observers. Its fate divides into 4 possibilities, each with a telltale signature. The simplest, it survives intact. In that case, it reappears with brightness, matching pre-conjunction forecasts, compact coma, and a steady light curve. What most comet scientists expect, if not the most dramatic outcome. The second fate is fragmentation, spacecraft coronagraphs. SOHO's LASCO C3, Stereo A High 1, and Parker Solar Probe's WHISPER would likely catch an abrupt brightening, often more than a full magnitude. Instead of a single point, images might show a string of fragments stretched along the orbital path. The dust cloud would swell, the coma blur, and the tail could split or kink. Past breakups such as C/2011 W3 Lovejoy and C/2012 S1 Ison showed these clues: sudden outbursts, bifurcated tails, and multiple points of light. A rare bright sodium tail, glowing yellow in sensitive filters, can also flare after violent disruption. Third is dormancy. The comet reemerges, but activity collapses. The coma shrinks, the tail fades, and the nucleus looks almost stellar, faint and unresolved in solar glare. The brightness curve sags below forecasts, and ground observatories struggle to recover it. Several faint sun grazers have limped through perihelion, this way returning so quietly that only careful analysts notice. The last and most dramatic outcome is total disintegration. The comet fails to return. No fragments, no sustained outburst. Only a brief, ghostly dust trail or a transitory brightening as the nucleus vanishes. Each fate leaves fingerprints: a clean light curve, a sodium flare, a fragment train, or a vanishing act. Watching the sky. Recovery starts with spacecraft. Images and ends with a worldwide relay. SOHO's LASCO C3 posts. Quick look frames every few minutes. Comet hunters scan for the first hint of 3I/Atlas faint point, sudden brightening, or distortion. Any anomaly triggers alerts. As soon as the comet clears, solar glare, wide field surveys like Zwicky Transient Facility and Pan-STARRS sweep the area, comparing new images to star catalogs and flagging moving or brightening targets. Multi-filter photometry tests. The case: a steady rise favors survival, a jump hints at fragmentation. Amateur observers then fill gaps, confirming positions and brightness, with modest telescopes and rapid uploads. Together, spacecraft, robots, and backyard scopes build the recovery record. For the public, a nearer prize is visible now. On clear pre-dawn mornings, Comet C/2025-06, Lemon, glides through Cancer. Look 1 to 2 hours before sunrise low in the east. At magnitude 4 to 5, it appears as a soft patch with a short tail. Binoculars 7 by 50 or 10 times 50 reveal it even in suburbs if you know where to look. The next 2 weeks are prime as Lemon climbs and the moon stays clear. By mid-November, it fades into glare. Treat it as training, reading charts, or an app. Timing the rise and tracking. A faint mover are the same skills used for interstellar targets. Another comet, C/2026 R2, Swan, should reach binocular range in early 2026. Its standout feature is a vast ultraviolet hydrogen corona, first seen by SOHO Swan instrument, a signature of water breaking apart in sunlight. Comparing the light curves of Swan and Lemon will help researchers probe outgassing, fragmentation, and how icy bodies erode under solar heat templates for interpreting future visitors. Thanks for watching. Don't forget to subscribe to Epic Dive for more amazing documentaries.